Kristen John, who's going to talk about dust mitigation. So it's a great introduction.
Great. Can you guys hear me okay?
Yes.
Awesome. Okay. So yeah, I'm Kristen John. I'm from Johnson Space Center. I'm in the engineering directorate in the spacecraft performance and concept engineering group. And so my current role is the discipline lead for dust mitigation for HLS. So I work with a few folks doing dust mitigation on but obviously it's a much bigger effort. And I'll touch a little bit on some of the stuff Michael mentioned and how we're kind of working across the agency to solve the dust problem. Okay, next slide, please. Okay, so the dust problem. So I think we're all pretty familiar here. And, here's another picture of Gene Cernan, our favorite astronaut to use to talk about dust mitigation. But I think, when we, talk about the dust problem, it really is, obviously it has all these implications for, clogging mechanisms in the breeding surface and impacts to human health toxicology. And so it really is a problem that needs to be solved. So next slide. So one thing I like to talk about is with the different folks we work on with dust is lunar dust is inevitable. We're going to see lunar dust, and dust mitigation is not a new concept. Obviously, it's something that had to be done during Apollo and something we've been thinking about. But one thing I'd kind of like to a point I'd like to make here is that mitigating dust is critical for the success of lunar surface science investigations. So, dust mitigation is a problem we have to solve, but I think it's also something that's very necessary in order for the surface experiments and the surface investigations to be successful. And so this is, something I like to say is that, whether you like it or not, you're going to have to deal with the dust. Okay, next slide. Okay, so one of the things about dust, right, is dust knows no boundaries, and so that can be true for all sorts of things. When you're talking about whose problem it is, who's going to solve the dust problem, where dust is going to go, what mechanisms it's going to interact with, what systems it's going to affect. It doesn't know boundaries. So therefore, dust is everyone's problem. And so, like Michael indicated, just a year ago, today even we didn't, we've come a long way in kind of addressing. All right, this is really an issue that we all need to be working on. We all need to be solving. We all need to be working together. And so, therefore, an integrated dust mitigation strategy is key. So, Michael talked on that a little bit, and I'll try and touch on that a little bit more. Okay, so when we talk about an integrated dust mitigation strategy, the first thing I think of and we think of when we talk about, mitigating dust and dust management are the different steps. And so a lot of people jump right to the technologies. But before you even do that, you have to understand, can you tolerate dust exposure? If your system can be exposed to dust and that's okay, then we can leave it at that. And then we need to be able to understand how much dust is in our system or our habitat or whatever it is that we're looking at. So detecting the dust, monitoring the dust, and then obviously we want to control how much dust goes into our system that we're talking about, how much dust comes in, and then after that, that's when you start talking about removal of dust. And so technologies have a role in all of those steps, but I know a lot of the tools and technologies that we think of take place during that fourth step there. But then there's also, there's operational things we can do, like how we mitigate dust during EVAs, and then there's architectural approaches as far as the designs of spacecraft. And then there's, as Michael mentioned, passive and active technologies. And so, that's there's different ways to solve the problem, depending on what system you're trying to mitigate dust on. And then as far as the different systems that are affected and the different assets that are affected, like I said, dust knows no boundaries. So whether you're on the surface, you're going to get dust, but that dust is going to come inside your habitat. It's going to affect your different elements and potentially get up into your orbital assets. And so we have to be aware of it. Everyone has to be working together on this problem. And then as far as the systems, again, every system that interacts with the dust directly, of course, is going to be affected, but then dust can get transferred here and there. And so we have to think about dust from that perspective. Okay, so for Artemis dust mitigation, it really is an integrated team effort. And so I've put kind of a list of the different groups at NASA that are working together on dust mitigation. And so it's pretty much all of us. We've got folks from HLS, folks from STMD, Orion, Gateway, Lunar Surface Systems, which is sort of all encompassing. It includes some new initiatives going on, the CLIPS payloads, Human Health and Performance, the EVA office. I put here the Astromaterial Science Division, but also other planetary science groups throughout the agency, the crew office, the Flight Operations Directorate, the suit folks, which is what we call XEMU, and you'll hear more about that later today, the EVA tools, and the ECLIS system, the life support systems, and even more. And then as Michael pointed out, obviously this is a bigger effort than just NASA. And so through SBIR and the modeling initiative that's going on, there's a bunch of different initiatives where universities and small businesses are also contributing to solve this problem. And so, we can't go into a lot of the details as far as HLS is going right now, but we're obviously working with the vendors as well. And so this is an time, and I think there'll be more to come on how the dust mitigating will go down for the landing systems, but it really is a team effort. Okay, next slide. Okay, so I stole this from one of the emails that went around from the Lunar listserv this week, and John Gruner had put this quote out there, and I thought that was really interesting. But it's Arthur C. Clarke quote: "The crossing of interplanetary space, though a technical problem which will challenge all man's ingenuity and resources, is not an end in itself, but merely a beginning. There is no point in going to the planets unless we do something when we get there." And so that's really where I like to drive the idea that this is a collaboration between science and engineering, and that dust mitigation is an engineering problem, but there's a lot of science that can benefited from doing dust mitigation, and hopefully science that can be learned while we're interacting with the dust. Okay, and so kind of with that, is that the dust problem is cross-cutting, and so it's, I think it's in the name, right? So lunar dust mitigation. So if you go to the next slide, when I think of lunar, when I think of the moon, I think of exploration. I think of going somewhere, of human exploration, humans going to the moon. And the next slide, when I hear dust, I think, naturally it's scientific thing, and there's a lot to be learned about the dust and the regolith. And then when I hear mitigation, I think of technology. That's the first thing that comes to my mind in engineering. And so I really think dust is a great problem where we can get engineers and scientists working together to solve this problem. And then as far as the role of dust mitigation in lunar science, this, because this is a science workshop, that was one of the things I was trying to drive, is that, in order for your science experiments to be successful, you need to mitigate dust. And so, Viper is an example I like to use, but, Viper is going to be, moving around through the regolith, so they need to protect different mechanisms from dust. If you have a sample arm, for instance, you need to, be able to mitigate the dust so that you can operations. Obviously, imagery, optics, solar panels, we want to protect those surfaces from dust. So in order to do successful science, we have to mitigate dust. Okay, in the next slide. Is about the scientific value of lunar dust. I think I'm preaching to the choir here, but obviously we've learned so much from the lunar dust since the Apollo days, and continuing to learn more about it through the ANCSA investigations. One of the things I thought was interesting was, just by looking at the images of the boot prints, we were able to get information about the porosity of the regolith. And there were other surface experiments, like the LEAM experiment that was part of the all set package. But in general, I think we have opportunities now as we send more and more payloads back to the surface to work together to do science investigations and dust mitigation efforts and benefit from each other on that. Okay, so just to kind of summarize it here, what I know for sure: we are going to the moon. We know there will be dust, and we know we need to mitigate the dust. And so, if all that is happening, what can we do? How can we leverage dust mitigation to learn more about the moon? Because I really do believe if we're going there for a reason. We want to learn more about the moon. So that brings me to my last slide, which are the questions. And so the questions I get working dust mitigation across JSC is, what simulant should I use? I get that question all the time. And then That's probably the most common question. And then another question I get a lot is, how will the regolith be different at the South Pole? And so I've talked to different scientists and I've gotten some different explanations on this, but I try to answer that question as best I can. But I think most of you here would be better posed to answer that question. And then a question that I have for this forum is, like I said before, how can we leverage dust mitigation in order to learn more about where we're going? Thank you.